Hello everyone, this is Steve with Class A Surfacing, and today I'm going to talk about, I would say, is the second most controversial subject in the world of CAD, and at least in my world, and that's tolerances and approximations and smoothing and that type of thing. The reason why I want to get into that is because of some very important and extremely powerful settings that ICEM gives us, and I'm using ICEM shape morphing right now to demonstrate this. So what I've done is I've set up a 3D curve, and then I combined them, and then I did a mirror to get this curve. Now, if we look at the math on said 3D curves, very simple math. Okay, it's a single segment, 2 degree or third order, single segment, third degree, or second degree, third order. And then if I look at the combine, well, we have several segments, but we don't know what the order is, okay, because it's a parameterized spline, just the nature of the way CATIA does things. But we know already that this is a more complex curve than these two, because these two are driving that shape. Let me go ahead and hide these. Now, I'm going to turn on dress up for this curve. This is just mirrored of that, so it's, just like that. Turn them all on, and you'll note here there are my segments. Segment here. And if I were to go into control points and pick the curve and just allow the system to create whatever, you'll note what the control polygon based off of that curve looks like. It's a fairly complex curve, which means it's going to, I just canceled out of it to not have that curve, which means anything that I create from that curve is going to be a fairly complex surface. Okay, now if I double click on this, you'll note that I have the two curves, long directions. There's nothing in here about tolerances. There's nothing in here about smoothing. There's nothing in here about anything. Now, I've done videos where I drop some curves on it and maybe redraw things, or maybe define my 3D curve in that position, different ways to simplify that. Or, because ICEM allows us to do some pretty incredible things, I'm just going to use the tools in ICEM. So to start out, I'm going to go in there and create a blend surf. Now with the blend surf, notice you have edge and support, edge and support. I'm just going to go from edge 1 to edge 2, and I'm going to apply that. Now I'm going to look under approximation. One of the nice things about these surface creation tools, some of the features that we have inside of ICEM, is that it gives us the ability to, on the fly, look at what's going on, output, results. I have a location deviation away from, these are my guides, and it's showing me that deviation. And I'm just going to turn on automatic, hit apply, and now we can see that there's no deviation, everything is spot on, but the complexity of said surface is pretty high. I'm going to select OK. I'm going to pick that surface. I'm going to go into dress up, and I'm going to turn on control points and segmentation. So control points are that blue, and the segmentation is green. Okay. I am going to apply. And just like that, you'll note I have 1, 2, 3, 4 segments. I have a whole lot of control points. I'm going to double click on that. Now, if I look at my approximation, go to more info, well, you look at that. Okay. So I'm getting a fairly complex surface. Even though, in theory, right, if I were just to take the curve that I use over here, extruded it out, and split it to here, into here, I would get that surface, but just an extruded, simplified surface. The reason why it's complex is because this is a compound curve. This is a compound curve. Now, One of the reasons why you may want to go through and create your surface like this is because you're eventually going to modify the control points to add crown to this, which we're going to get into a little bit later. But for now, under the Approximation tab, I have the ability to say, all right, well, I want to deviate a little bit. So I'm just going to turn off Automatic and hit Apply. And notice the surface simplifies quite considerably based off of my inputs. I've told it that the max order is 5 and the max segmentation is 1. Now, on top of it, I'm saying allow this to deviate up to 1/10 of a millimeter. And for G1, if G1 were a thing, but in this case it really is not because I haven't applied tangencies on my blend, I could also adjust the allowable tolerance for that tangency and additional smoothing. So if I turn the smoothing off on this, you'll see I get a slightly different result. So this is an additional smoothing factor. Maybe we'll talk about this in another video. I don't want to get too deep into the weeds on this because I do want to get into some methods, things that I do. And now that I have that surface created, you'll note once again, it is an order of 5 with a segment of 1 and an order of 2. All right, so if I show me the UV, here's my V, here's my U, and I have a very clean surface. And I am deviating very, very little bit from this curve. Now, other places that I do use this is when, all right, like I'm going to make another surface come down on the, from that corner down. And I don't want that surface to have all of that complexity, and I want to approximate it, smooth it out a little bit. And to be quite fair, chances are this little amount of deviation in the long run really means nothing. And the reason why it really means nothing is because when I go in and create the blend between these two, whatever slight little deviations along that edge that may exist aren't going to matter at all. Okay? So the tolerances in CATIA, ICEM shape, so on, by default are at a micron, 0.001. And for some things, I want that. But for this, I don't care. It's close enough to the curve. It's close enough to that shoulder that I put in that theoretical. And I got a smoother, cleaner surface. So these approximations allow you to specify, well, really, how complex do I want that curve or surface to be? So if I come in here and I change my order, hit apply, you'll notice it comes in and says, oh, I cannot do that. Not to the tolerances that you currently have specified. It wants to deviate a whole heck of a lot more, and it tells you how much it wants to deviate. Okay? So if I go up, hit apply again, it's going to come back and yell at me. Still wants to deviate. Well, it's more than I'm willing to deviate. Now, I'm just going to play around with this just a little bit. If I up this to 2, hit apply, still not enough. You'll see the deviation it needs to go is less than the prior ones, but it's still greater than what I am allowing. So this gives me a really good indication. Man, I'm getting there, but it's getting pretty complex. Let me just go up quite a bit, right? So there is my segmentation and what that looks like, but I'm holding that tolerance that I've specified. So this is where playing around with these numbers, where I had this at, oops, go back down to 1. That's really where I want it. Really, I really want to keep this as simple as possible, clean as possible, and so on and so forth. All right, now I'm going to hit OK to generate my surface. And that looks really nice. and it's a simple surface, and it's a clean surface. Now I want to add a little bit of a crown to this. And this is where, under modification, I kind of talked a little bit about this called feature modeling. I think I talked about this. Maybe I haven't. I apologize if I haven't. Now what feature modeling is, it says, all right, well, I want to modify this surface blend, and there are different ways. There's no constraints. There are intrinsic constraints. Maybe we'll talk more about this feature later on, but for now, I'm going to go specified constraints. And the reason why I want to use a specified constraint is because when I go into modification, I'm sure some of you have seen this menu before. Feature modeling. This looks exactly like control points. What I'm doing is I'm adding a feature to that blend, and I want to be able to modify the complexity. So I'm going to basically hold these ends, so I can come over here, say G0, say G0, and hold those ends right where they're supposed to be at. And now I can begin crowning this. So I want to crown it. I'm going to come in here. I'm going to use the mesh. I want to make a symmetry out of this. So symmetry to the ZX plane. And so now, let me turn up my attenuation a little bit so it doesn't erase around. I can begin crowning it because now I'm holding this symmetrical. This has to be symmetrical across that center line. Now I can come in here, go with points. These two are symmetrical. Maybe I want to bring this up. Maybe I want to bring that up. Okay, maybe I don't want any of these. Maybe I want independent, etc., etc. And just like that, okay, I know I've been lecturing for a little over 10 minutes at this point on just to get that surface, but if you just saw those control points, you saw exactly what that looked like. Control points, segmentation. Actually, let me turn off curves. I want control points, segmentation, display control points on edge. I don't care about ISO curves for now. You know what? I'll display them as purple. The heck, why not? Select OK. And what I end up with is a very, very clean surface. We'll call it a mathematically responsible surface. And the nice thing about modeling something in this fashion is, because we were always talking about parameters and parameters that, and the magic of parameters. So if I come in here, make a little modification to this curve, everything holds. Everything's right there. Okay. If I go into analysis and I want to take a deep dive look at this, let's go to highlight lines because I'm a big fan of those. Right. Again, very clean surface. Very, very clean. Everything flows nice, mathematically responsible. It meets all the requirements for a Class A, right? For those people that want to hold to a super strict, stringent standard that was derived decades ago for good reason, before somebody decides to yell at me, and maybe I'll talk about why those super strict old Class A standards exist. You know what? I'm going to make a video about that. I think everybody should know the history on why they're there and why we can faff around with the numbers a little bit these days. But anyway, I have a very clean surface. Let me go ahead and turn that off. And once again, I can go in my feature modeling. The nice thing about my feature modeling, notice I have my continuities because I locked those down. Even over here, when I was on this menu, I locked those down. You notice my options. So I can lock those. Now if I go into more info, this is going to show me the deviation from the original surface, which in all honesty, in this case, I really don't care because I'm deviating a significant amount. I need to puff it up in the middle to meet whatever requirements it is I have. And boy, I can make some good looking surfaces that way, quick and easy. All right, let me double click on that. Let me go like this. Go like this. And as you can see, the combined curve is updating and changing, right, where those segments are at. But because I'm a smarty pants, and because of the way that I built it, and because of what ICEM allows me to do, I got a very clean surface. Okay, so now, say I wanted to build a flange off of this. Go to Surface. There's a tool here called Flange. And you know, you got shell normal, proportional, tangent, direction, so on and so forth. All right, I'm going to pick my curve. Okay, what is my direction? I'm going to just pick the XY plane. I'm going to hit Apply. Now with that, this gives me the plus minus. Actually, let me change the length of this. Whoops, I hit Enter. And notice I have it currently set to, and this is another tool I'll talk about separately in another time. Okay, so I have that. I have my angle. All right, I can go into advanced. I have overcrowning, so if I want to overcrown this just a little bit, doesn't have to be a huge amount, just a little bit. And approximation. Let me go into more info. Right, so it's creating a surface that I don't particularly like. It's not super complex, but it's, let's say, more complex than it needs to be, again, because of the curve that's driving it. So I'm going to turn off automatic. I'm going to say, you know what? Deviate a little bit more. Link these. Let me drag this down a little bit. Okay. A little simpler. Is it really what I want? My max order is 5. Min segmentation is 1. You know what? I want a max segmentation of 1. So this is going to change around a little bit. You're going to come back and say, wait a minute. I can't hold that tolerance. And that's fine. I got to go up a bit. So I'll go up to 0.1. And if I really want to see where the deviations are at, it's on that curve right there. That's what the tolerance is to. But now, you know, look how simple that surface is. Okay, it's a much cleaner surface. You know, I have smoothing options if I really want to. I can start playing around. Maybe, like I said, I'll talk about some of these other things in maybe other videos. And I'm going to leave the crown just like that. Now, if I hide this curve and I do a zoom on it and I look, you know, the chances are you're going to find tiny little gaps along that thing, but they're minuscule. Okay? They're absolutely going to be minuscule. And quite often, what we do is put a blend on that, right? Crazy, right? We put a blend right over the top of that. And if I were to do something like, oh, I don't know, a freestyle fillet. We go to G2. And let me go up to 55. Make it a bit bigger. A little too big. Whoops. I should read what I'm typing, right? That's important. And I'll just trim, extend it all the way out, trim everything back. And now for the blend, right? We have max order 6, segmentation 3. We expect this to be a bit more complex. And if I really, really want to, I can play around with tolerances, and I don't really, really want to. Now, if I take this and say, all right, well, my distance tolerance really has to be tight, because I know some places like to have a very, very tight distance tolerance, which, quite frankly, I do not blame them. You may slam this down. The old Chrysler days, it was 001. This is I think 0.1. Right? It really doesn't affect this too much, but you see max deviation, everything is just perfect. And I'm going to select OK. And I got my blend on there. Okay. Now, if I look at the highlights on this guy, I would, other than just me slapping something together, I beg you to find something wrong with that. Right? You won't. It's perfect. And again, if I want to show the control points, segmentation, what we have is a very, very clean blend. Okay, now the nature of the blend that I put in is going to put in these segments, and because of the tool that I use and the tightness of tolerances and all sorts of other stuff. But I do have other things here, like small surface stitches, if I have something very small, if I want to rip things apart, and that type of thing. All right, I have a lot of other options in here that'll, of course, generate far more complexity. I have G3 if I really want to go all the way up to G3, right? I can slam that thing all the way up, super complex. And again, I have my Approximation tab. Okay. Now, max order, well, I'm going G3, so this really should be at least 8. And, we get something a little bit cleaner, a little bit more reasonable. Okay, default parameters, which, how do you want the parameters to look across that? There's ways you can pull in and out and automatic. Maybe I want to manually determine max segment. Right? Let me go down to max segmentation. Let me apply that. And as we do that, let's look at what some of the changes happened. You'll notice a slight deviation here in G2, which is fine because I have enough math to put that blend in and clean it up. And somebody will look at this and go, well, why is this overhanging over here? For the newbies, people that don't understand, I told the system to trim that blend. Right, I want to extrapolate to the edge, and then relimit, so I end up with this. If I don't have the relimit on, you'll see that blend runs all the way out long. If I'm, really, what I typically do in a case like this, I don't ever trim the supports. I don't say ever, but more likely not to trim those supports. Extract those curves and maybe use those curves for other things. Or I draw in the curves that I want and then put in that blend in different ways. But, when I look at that, I see something of beauty now, right? I see something very simple, something very clean. And once again, for anybody, for everybody out in the bleachers that don't have a channel, probably haven't done that much surfacing in their lives and, want to yell at me about what I'm doing wrong, hey, go for it. But I know this works. I know that's a very clean surface, and look at that. How beautiful is that? Really, really nice. And again, because of the way that it is built, let me actually come off to the side. Let me come over here. Double click on my curve. Bring this up a little bit. That down a little bit. This is the kind of power that ICEM has that a lot of other CAD systems don't. ICEM IDX here inside of CATIA, inside of 3DEXPERIENCE, is that, if you draw things correctly like this, where you have curves driving things, and I don't have to have curves. I can just put in surfaces and overlay. But I'm a big fan of driving things with curves because I can inspect those curves. I can do a lot with those curves to drive the math that I want and the shape that I want. And making these kinds of modifications right in the middle of a design review is pretty remarkable, right? Being able to sit there and have everyone say, well, we want the surface to do this, that, and the other thing. And within minutes, you can do those kinds of changes. Now, you can build like this very similarly inside of GSD, right? Generative Shape Design will allow you to build very similar to this, but the difference between here and GSD is I can control the amount of math on those surfaces. I have G3. I have those crowning features, the feature modeling, where I'm parametrically making modifications and so on and so forth. Because if I go back in here and double click on that feature, I'm going back to that original, right? I'm not modifying it again. I'm remodifying it, right? I'm going in there. I forget all the time to apply my symmetry plane, as I'm so used to stuff like this. And because it's applied as a feature, it remembers the symmetry plane. It remembers the modifications that you've already done, right? If you go to options right over here, you notice I can hit reset. I'm not going to do that right now. But if I were to go in there, I'll do it. Why not? If I hit reset, whoops, I can hit the buttons. You'll see it takes it right back to its original everything. So it's like starting off from scratch and kind of building that surface. Maybe it's easier to start from base and work your way back up again. Okay, so those are just some of the very simple methods that I've come up with over the years. And the beauty of this ICEM tool is that not only is it incredibly fast, not only does it build incredibly beautiful surfaces, but you have a certain level of parametrics that's almost unrivaled, right? The speed at which you can make modifications. Because as we all know as designers, it's not how fast you can necessarily build something, it's how fast you can modify that thing you've built, because it is going to change. And this is where the real power of ICEM, it takes CATIA, which is one of the ultimate CAD tools in the world. Regardless of what anybody on other CAD systems say, it's really one of the best. It's tops. Like, it's between one and another one. That's it. Then, not to poo-poo anybody, at least for me, because I've used a lot of other CAD systems. But this kind of power, this kind of ability, this kind of capability, the speed at which it happens, and then I can take this if I'm doing composites and throw it into the composite application and go right into apply layups, or if I want to do sheet metal forming, or if I want to do plastic injection molded, right? I got all that stuff embedded right here, right at my fingertips. So, and then, any change you make can propagate through the entire process very, very quickly. So, we'll be getting more into some of these features and more into how some of these other tools are applied as we go on. But this video is long enough. Anyway, hope you liked it. Hope you learned something. I'm going to cancel out because I like that. And again, if you have any questions, comments, please feel free to ask.